Okay, so tonight we're going to talk about sources and sinks, which have been driving me crazy all week, trying to figure out how this all works. So what you see here on the screen now is the old way. And what you do, this is in the Auto.network network. They had you create a flip tank, which will give you this and this whole bit and a bunch of other things. The initial, the fluid, all this stuff. And so you have a flip tank. Now you want bubbles. And you need either a source or a sink. Now this is in terms of the filter. And if you think of the aquarium project, if you look at aquariums, they either have something where the bubbles are coming up from the top. Coming up from the bottom. You have something in the tank that pushes up your aeration, or you have something on top that spills water down and sucks it in and spills it back down, doing the filtration that way. So that's where your sources and sink come from. So when you do this, the next thing you want to do is create a sphere, or whatever your source is going to be. In this case, we have a sphere here. Okay. Now, in order to get that in here, first of all, and this is very important because was the cause of much frustration on my part. Your sphere has to be within the flip tank. If you're doing a source, which is what we have here, you see it's within the flip tank. Now what you do then, here's something else. I'm going to leave this pinned, and I'm going to go back up. Split your panes. So you should do some kind of quad setup here. And you need to have both of these up, because what you're going to do, and I can show you, let me just show you from a new file. All right, because that's going to make the most sense. All right. So first thing, flip tank. We put our flip tank down, and there we go. We got a flip tank. Now, this is our waterline. Notice it created this initial, which essentially what it does, this is the old way, and it's kind of annoying how they have these over here and not next to your dot network. This is your key. This is your dot network. So you have a flip tank, a flip solver, a merge, gravity, etc. Now we're going to go up to the object level here, which is where we are, actually. We're going to create a sphere. So let's go here and hit sphere. And we're just going to put a sphere down. And I'm going to move it up a little bit, not much. Because remember, it has to be within our, let's pin this, auto.network. So we got our flip tank, we got our flip solver. It's within the flip tank. And now what we're going to do is click on this, and we're going to say, let's see. You know what? I'm going to do it this way. I'm going to stick this, move this under a little bit. Again, it's still in the flip tank. Let's make sure. No, it's not entirely in it. So let's move it up. And we're going to move it from just under the bubbles here. All right. So we got a flip tank. We got a sphere which is in it. And what we're going to do, we're going to select the sphere. And we're going to say sync from object. And it's going to say select fluid out. So select fluid, okay, because we already had this selected. So we're going to go flip tank. And oh, it didn't like that. Okay. Let's start over. Select fluid. This should have been pinned. All right. And we do this, and that is it. No, it's not taking it. I ran into this problem. And let's stop this whole thing. Let's go to the sphere. Let's go out of the sphere and say sync from object. Select object to create sync from and hit return. Hit fluid object to add sync to. And I think this is what we want. Let's see. We hit the flip tank. No, it's not getting it. Okay, so you can see this can be a little tricky. And now what it does is it added the create sync. It added in the auto network. You go up here. Now I'd recommend pinning so you can reach either of them, but it seemed like what worked was clicking on this. I think it's easier just to do it manually. Look at the example here. And in our auto.network, notice it did source sync. So when you go here and you look at go back up here. And notice what's happening. Now this has to do with the water level that's not set here. But you can see, so it keeps dropping. You're going to have to play with the water level and things like that in the flip solver. You go to the flip solver here. No. Auto.network. Flip solver. Okay, so I believe even in here, you can set some kind of waterline, use waterline. So you can set the waterline to, let's say 2. And then when you do this, let's bring it down to just plain old 2. What's going to happen is it's going to, it's still falling down. You probably they have this reseating, and I think that's not what it's doing with this. And then you can flip these two things over to sources. This is going to This is not reseating, this example here. But you get the general idea. What you're trying to do, now let me go back to the example I have, which is a source example. And if I recall with this, sometimes you have to worry about the fact that you're still getting, particles replaced. So when here we got our auto dot, if you look at this is just gonna, and this stays pretty much the same. And let's go into the auto dot network and the flip. I think this is use waterline, and I have the waterline direction, but there, I believe, in particle motion, there is something, reseating. So this is a key. I believe this is what the key is. You have to have some particles constantly replacing the ones, or it is going to sink. So that's the old method. Now the new method, let me show you that, is much easier. And basically, you don't have to mess around with trying to grab one thing, or do it manually, which I think is easier. Trying to grab it at the right time and in the right order. Not something I particularly, it's kind of a pain. So I would say find their example, look at or this example, and then you'll see how it is configured. But I'd recommend doing the new version because this is where it's going. Now, in this case, again with the flip solver, you should have your waterline, and I believe there is something similar involving making sure that you're getting you're getting, I'm trying to see which one it is. Yeah, here we go. We also have reseating here. So anyway, now this is another thing. I want to see if I'm using this. There is something called air compressibility, which supposedly makes it could be helpful in terms of getting your bubbles. If you use this, you have to go into advanced and make sure this is checked off. But let's get to the key. The key is this: so you create the sphere, which is underneath, which means this is a sink, and the flip boundary, again, it must be within the flip boundary. And if you look at it, it must be within the flip container, which is this. Our sphere is here, right there. And our flip boundary. Then our flip solver. See it right there. Oh, let me turn our flip solver. So you have a flip solver, and this flip boundary here, you see, you make it a sink underneath. Then you can, to get things going, I use velocity here, And unless you're using velocity from deformation, I don't think this does anything. This, when turned on, okay, this controls the speed within the normals. This isn't how much additional velocity. This is how you get it to kind of, spurt up. So notice what's going on, how well this is, what this is doing here. It kind of spurts up and then it is kind of going, and you're getting some water motion right here. And if you stop this and you render it, I think you will. Oh, the other thing is it may stop when it. Well, let's see. Let's look at this. Let's see. Open render view. And oh, you may see this. That's because this needs to be selected, or it's not going to like that. Notice the deformation here. So let's do this again. So if you see that error, make sure you check. You can see you got the motion here going on. So that is kind of the new way of doing it, and you can adjust these parameters to get what your desired result. And so I decided to try to do this in our, see if I can find that. Here it is. Yeah. So this is the example we've been working with. Now notice this is a little too powerful here. And you can adjust the size of the sphere. Let's go back and you'll see what happens. So you can see this huge water spout. So you obviously want to make this a little bit smaller and less powerful. You can see how a block is going to go right through it. But this could be kind of the basis of getting the bubbles of water movement in the tank. And again, the video that I recommended last weekend, that talks about this as well. They do go into this in part of the video. And that was kind of the source of frustration, because I think, oh, I'm trying everything this guy's doing, and I'm not getting anything. Well, again, it turned out that again, you have to have your emitter. In this case, it is this object, this geometry. You have to have it within the flip container, or it's not going. In fact, look at what's happening with this flattening. I'm going to try to get this to render and see what I got here. So you can see it's coming in. So the cube pushes right through it, and of course the other cube is underneath. And this is another sphere I created that would actually, for this, may be even better. Actually, let's see something. If I tried that instead of sphere object, do I have another? Let's see. cancel. I thought there was another sphere in here. Oh well. But you can see, obviously there's a lot of it. I'm going to have to do some adjustments. I'm thinking maybe we want, you know, some kind of, you know, points on a geo or different. I'm trying to think about the best way to do this. But the basic concept is you have a source or a sink. Well, you have a geometry. If you want it to flow from above, it's a source. If you want it to flow, let me close this, from below, then it's a sink, and it has to be below the water line. Source above, but again, they must be within the flip container. Then you can adjust which one it is based on here. For a source, you don't really need the boundary. You can make it none. For the sink, velocity is kind of helpful. That's the one that is recommended there. And you can adjust additional velocity, whatever you need to get the result that you want. So hopefully this has been helpful. Like I said, I spent some time trying to understand how this stuff works. There are not a lot of good examples out there. And the example on the SideFX, you know, involves using the shelf tool, which I found a bit of a pain. So that's why I showed you exactly what you need, which is basically, you know, it's just going to be quicker. You're not going to be, to create these nodes manually. This is the new one. Create the nodes manually, like we saw with the where you tell it it's a source or a sink. You stick that in your auto dop and bring in, you know, you have your geometry. It's going to take a second here. But that's the way you did it in the old. In the new, you just use this flip boundary to control it. Again, where you put your geometry relative to your water line. And well, so in this case, you just add this. This is actually a volume source. And, you know, they give it a name, so it can get a little confusing. And within the sphere, you add a flip dop source. So, flip dop source and the volume source in the AutoDop network, the old way. The new way, the flip object takes care of it. Everything must be within the flip tank, and that's pretty much how it works, and that's how you can control simulations. So we will take it from there. I'm also doing some little work on grains, because I think that's a good thing for our substrate or gravel, if you will. And I'm going to try to put some of that together for next week. So anyway, I will speak to you next week, and take care.